I have a very typical trig question that appears on the exams. What I want to do is share with you how to solve this type of problems and what's the easiest way. Let's get to it. The key to solve this problem is realizing we have two terms that's really multiplying each other. So this is equivalent to say a equal to 0 or b equal to 0. What you really don't want to do is multiplying those two terms together. You'll end up with a big mess of cosine x, sine x, plus half of, let's see, what do I have? Cosine over here, minus half of sine x, and then you have minus half. You really don't want to do this because now you're littered with different variables scattered all over the place. Okay, so what we really want to do is keep it simple and use it here. This would actually get you to cosine x equal to half, which you can solve easily, or sine x is equal to minus half. Okay, that's a lot easier to solve. Make it clear. And then let's dive in here and solve from there. Alright, let's clean up our little workspace here, and what we really have then is a solution. So we have two things to solve: cosine x equal to half, or sine x is equal to minus half. Okay, so let's solve this chunk on this side. We have cosine curve. Now there's two ways you can do this one. I'll show you both ways and you get to pick whichever way works out better for you. What I draw on here is that this is the cosine x. It goes from 1 to minus 1. There's no magnitude, and here is our 360 degrees. Half is right smack in the middle here. Okay, so it's one angle here. If you draw this angle value across all the way, you'll see there's two alphas, alpha 1, alpha 2. Knowing the trig table, this one would give you 60 degrees. Alpha 2 is going to give you, let's see what's on the other side, it would be a 300 degrees. Okay. Now, alternatively, you can solve using a unit circle, which actually I prefer when it comes to cosine and sine. The simple reason that in a unit circle you have the hypotenuse equal to 1. Given the hypotenuse equal to 1, since cosine is adjacent over the radius, here's our half. Drawing over here, I see the angle right away. That's this one, it's 60 degrees. Now this one is backward, is minus 60 degrees, and if you were to draw the angle using the regular convention, that it has to be counterclockwise, so therefore this angle alpha 2 is equal to 360 minus 60 degrees, because this is the angle we really want going the other way. This is equal to 300 degrees. Either way, whichever one tickles you fancy, I suppose. Now let's get on to the sine one. I'll write a little quicker now. Alright, let's solve on this side. Let's clean our workspace a little bit. Started with drawing a sine curve. We have this, and then it's minus half, so our angle is over here. Draw a line. This is angle 1, angle 2. So let's call this beta. Beta 1 is going to be, let's say, 210, I believe, and beta 2 right over here is going to be 330 degrees. Now on the unit circle, let's draw it out a little bit bigger. Now sine is opposite over the radius, which is really saying that we're going to be looking at a y value. So this is minus half, and our angle, here's angle 1, here's the angle 2. Now, following the convention, this becomes our beta 1, and going all the way around, it's going to be our beta 2. Okay, so beta 1 is equal to 180, basically, plus another 30 degrees over, which is 210. That's this one over here. And then beta 2 is basically 360 degrees minus 30. This is the 30 here. That would give us 330 degrees. All right? Alright, doing a quick recap, we split the two terms because they're multiplying. This half is cosine, this half is sine. And cosine of a half, you can use unit circle or cosine curve itself. Either way, whatever works out for you. In the cosine curve, we're looking for half and drawing the line value wherever the line intersected the curve itself gives the two angles. Or in the unit circle, you're going to use the adjacent over the hypotenuse, which is the definition of a cosine. So cosine, we're really looking for x value, which is half. Okay, drawing the circle, and wherever they intersect the unit circle gives you the two angles. Sine on the other side is going to be a curve over here. Since we're looking for minus half here, drawing a line gives me the two angles. Or alternatively, using unit circle over here, since it's opposite over radius, which is looking for the y value, then it gives you the two angles over here. Alright, I hope this helps. Hi, this is Dr. Pan recording from Tucson, Arizona. Please comment or share this video. Together, we can make a difference. Have a confident day.